Hello everyone and welcome to today's webinar, Energy Efficient Mining for a Better Tomorrow, hosted by Mining Review Africa and Danfoss. I am Laura Cornish, Editor-in-Chief of Mining Review Africa and your moderator for today. I'm pleased to introduce our expert speaker, Stephen Brown, Business Development Manager of Mining for Danfoss. Before I hand over to Steve, I have a few housekeeping items to cover about today's session. First, today's webinar will be available on demand after the live session on Mining Review Africa's website and is accessible through the same link you're using now. Next, we'd love to hear from you during today's presentation. If you have a question for our guest speaker, please feel free to send it through the Ask Staff a Question box on the right-hand side of your screen. We'll be answering questions during today's session. If we don't get to your question during the webinar, we will be sure to follow up afterwards. And lastly, we'd like to encourage you to share today's webinar with your social networks. So before I do hand over to Steve, I would like to invite our audience to participate in a poll that we're running today. And our poll today is asking, have you had any previous knowledge of variable speed drives before today's webinar? There's a yes or no option, so I would like to invite you just to participate by choosing either yes or no. We run through that question again with you. Have you had any previous knowledge of variable speed drives before today's webinar? Please, you can select just yes or no. So I'm going to give our audience just a couple more seconds just to think about the question a little bit and participate with either a yes or no answer. And just one last time, have you had any previous knowledge of variable speed drives before today's webinar? Yes or no? Just a few more seconds. Brilliant. Thanks very much. I'm now going to hand over to Steve. Steve, thanks so much.
Laura, thank you very much for the introduction. And good morning, good afternoon, and good evening, depending on where in the world you may have joined us from. And welcome to this mining webinar on sustainable and energy efficient mining, where the focus will be on variable speed drives. And it's quite a very relevant topic at the moment, because if we think about the mining industry over the last few years, going back to the financial collapse a number of years ago, the mining industry got hit very hard. They were just starting to make a comeback, and more money was being invested in exploration and the building of new mines. And now we've been hit again with another pandemic. Now, mining companies are facing a lot of challenges now for future growth. And as demand for minerals is starting to exceed supply, the mining companies are searching for new ore bodies, and they're quite often in remote and inhospitable regions, especially on the African continent, where production costs are high. And in addition to this, they also want to improve their safety and reduce the impact that they're having on the environment. So to safeguard their future, mining companies, they actually need to improve their performance. They need to cut the production costs, as I said, reduce the environmental impact, improve their safety record, and also they're now looking to become more automated. Now, these energy intensive processes in these harsh environments and these remote areas, they demand robust, safe, and energy efficient process equipment. And what we have to remember is energy costs represent 25 to 30% of a mining company's operating costs. And this is especially true in remote areas where these energy costs are really a major contributor to the company's operating costs. Now, much of this energy is actually consumed by electric motors, and in many mines, and especially the older mines, the motors are running at fixed speed regardless of actual output requirement, and this wastes a tremendous amount of energy. And energy use at certain times in the day can be cut up to 60% if we can control these motors with electrical variable speed drives. And equipment in most mining processes is very often exposed to very extreme working conditions, such as dust, humidity, high temperature variations, high altitude, and quite often in Africa, weak network conditions. And these conditions put a very high demand on the equipment. So to ensure a high production output, the process equipment would have to operate reliably under these conditions. So let's have a look at what we will be presenting. Sorry, Laura, I have an issue with moving on to the next slide. Laura, can you hear me? There we go. Okay, so let's take a look at what we'll be presenting. We'll take a look at a brief look at who is Danfoss, what do we do, who are we? And then we'll look at the environmental impact regarding the motor's energy usage. How then, by reducing power losses, which is heat losses, these operating costs can be reduced, and how we can reduce these operating costs even further by using a technology we call back channel cooling. And then how the footprint, the actual size of the VSD, can enable a substantial cost reduction in the capital expenditure. And finally, we'll take a look at by using what we call automatic motor adaptation, which is abbreviated as AMA, during commissioning. These labor costs can be reduced, and by optimizing the drive and the motor to run at maximum efficiency, we can therefore save further operating costs. Okay, so who is Danfoss? Well, Danfoss is still actually a family-owned business with its headquarters in Nordborg in Denmark. As you can see, we operate in all corners of the world: Western Europe, Eastern Europe, in the Americas, Asia Pacific, Africa, and the Middle East. And within Danfoss, we have 4 segments. We have the drives division, where I'm situated. We have a cooling division, a power solutions, and a heating division. And our focus is on what we call 5 megatrends, which are digitalization, electrification, urbanization, climate change, and very importantly, food supply. Now, Danfoss has over 25,000 employees globally, and that, even for the situation where everybody in the world is finding themselves in, we are confident that this will actually grow in 2021. We have 72 factory sites in more than 20 countries. And we have a focus on female leadership, which is quite interesting in itself, because at the moment Danfoss has 20% female leaders. We are targeting that to improve it to 30% by 2025. And I also noticed that the mining industry is also looking at employing more females into the mining industry. And if I think back to my early days on the mines, when I worked on the mines, it was actually a very, very dominated male environment. And it's nice to see that not only are we getting female employees into the mines in some of the harsher areas, but also we are having mines owned by females. So that is actually very, very good. Danfoss is looking to become CO2 neutral by 2030. I'll make a statement because we've already made big advances towards that, and I would predict, even though Danfoss is saying CO2 neutral by 2030, I predict Danfoss will be CO2 neutral before that. And we have signed the UN Global Compact on social and environmental responsibility. And no matter where our companies are in the world, we always act responsibly towards any local societies. Now, what is not generally known is in 1968, Danfoss was actually the first company in the world to commence mass production of AC drives for variable control of three-phase induction motors. And today, AC drives are actually an increasingly important component for the actual optimizing of a motor operation and the systems attached to the motors. And we are seeing that AC drives are now used in an expanding range of applications. So 20% of the world's energy consumption is electrical energy. And very interesting, more than 50% of electrical energy is actually used by electrical motors. That's quite a staggering fact. 75% of AC drives are used on pumps, fans, and compressors, all basically used in the mining industry. And by the year 2040, if we could control the speed of motors or control motors with variable speed drives, there's the potential to reduce the global energy consumption by 8%. So if we look at fixed versus variable speed control, the most common flow method is by means of a fixed speed motor, where the flow is adjusted by a mechanical device. And by using this technique, it doesn't only waste a tremendous amount of energy, it also actually wears out the equipment. Now, with the electrical variable speed drives, changing the flow is quite simply achieved by just adjusting the speed or the torque of the motor. And as somebody once said, it can actually be compared to taking your foot off the accelerator pedal of a car. Now, if you think about that, if you have your accelerator pedal pushed full down on your car, yes, the vehicle's moving fast at high speed. If you lift your foot, obviously the speed of the vehicle will start to slow down. You'll still reach your destination, be it a little bit later. However, you'll reduce your fuel consumption, so you'll be saving money. And it's basically the same with a variable speed drive, and I'll go through the graph just now. So electrical variable speed drives are the most efficient control method. Why? Because they save energy, they decrease the CO2 emissions, which is a factor that all industry is looking to achieve, and it minimizes the total operating costs. Now, by utilizing a variable speed drive, it actually replaces the mechanical control devices, such as valves, fan inlet vanes, hydraulic couplings, and dampers, which are quite often used in the different mining processes. So if we take a look at the graph, and we switch on an electric motor, obviously it takes a few seconds to run up to speed. So if a motor runs at 100% speed, it will draw 100% of its energy consumption. In other words, it will draw its full load current, so it'll be working at maximum and drawing maximum energy. Does a motor need to run at full speed the whole time? Well, no, it doesn't, because at different times of the day, you get these off-peak periods, or you could have a conveyor belt that's not fully loaded. You could have pumps that don't need to be pumping, say for instance, slurry. The slurry may not be as much, so you don't need to pump as much slurry out. The same with clear water. So what will happen is the control of the variable speed drive will sense the load on the motor, and then it will actually reduce the speed to the requirement. So if we just look at a 20% speed reduction on the motor, you have a 50% energy reduction. So quite a substantial saving. Now, quite often when I'm in discussions with regarding variable speed drives, I often get the comment, a drive is a drive. So they, in other words, are saying, well, all drives are the same. Well, that's actually not true, because the high efficiency and the resulting low power loss, it actually minimizes the heat load on the switch room's air conditioning and its ongoing operating costs. So simply comparing stated efficiency ratings of variable speed drives from different manufacturers, that can actually be misleading, because they will all typically be and state that they're in the 96 to 98% range. But the factors included in those ratings can be different from one manufacturer to another. So, for example, the Danfoss drive incorporates a built-in, what we call a built-in DC link choke harmonic filter and RFI filter. And it can be installed with at least 150 meters of screen motor cable between the drive and the actual motor as a standard. And any losses in the drive associated with these filters are actually included in our stated efficiency rating of 98%. Now, manufacturers who offer these filters as options and need to fit maybe additional filters for 150 meter motor cables, they may not include these in their standard efficiency ratings of 98%. However, all manufacturers state the typical power loss from their variable speed drives and the associated optional filters for each kilowatt size, because this enables the correct sizing and selection of any air conditioning system which is servicing the switch room that the VSD is installed in. So a comparison of the typical power loss from the Danfoss drive with that from drives from other manufacturers, including optional filters required to give the same performance, typically results in lower losses and lower heat load on the switch room air conditioning from the Danfoss drive. This results in lower operating costs and can result in lower switch room costs for a project if fewer or smaller air conditioning systems are required for the switch rooms. So if we take a look at the graph, this is what I mean by saying that you can't put all drives in the same compartment, because you'll see that obviously we've got the Danfoss, and for reasons of ethics, obviously I can't mention the other manufacturers' drives. But if one looks at the lower, what we call the lower power range from 45 to 75 kilowatts, you'll see they're pretty much of a muchness, they're pretty much equal. However, when you start to get to what we call the high power ratings, from 90 kilowatts upwards, you'll see that there is differences between all these drives manufacturers that I'm showing here. Now, where can you get this information from? Well, just go onto any drives manufacturer's website, and this information is freely available. But you can see the differences between all the different manufacturers. So, as I stated, a drive isn't always necessarily a drive. There are differences that can save costs. Now, what we have here is a project that we did in Australia. It was a thermal coal mine, and the end user and the project company actually reviewed all the drives manufacturers involved that were tendering on this project. So what you'll see here, we have two graphs. The left is showing the coal handling CHPP, which is the coal handling production plant switch room, and the right-hand graph is showing the product coal switch room. So when they compared, again, you can see the differences and where the least heat, from which drive the least heat was emanating from, and compared with the others. And what this means is, and we'll come to this on a later graph, it shows that you can actually reduce the size of the air conditioning. And if you're reducing the size of the air conditioning, well, then you're reducing the running costs of the air conditioner as well. So again, we're looking at cost savings. Now, when we looked at this, or when the end user and the project house looked at this, they found that by using Danfoss, on average, it was a total saving of 5% of the total VSD cost. Now, we wanted to take that one step further, because we said, well, we can offer an even better solution whereby you can reduce that heat going into the actual switch room even further. So all the Danfoss drives, 90 kilowatts and upwards, incorporate what we call a back channel cooling design. And this has separate cooling paths for the power components and the control electronics. And we have an IP54 seal between these two paths. Now, this back channel cooling removes approximately 85 to 90% of the power lost directly through the heatsink. So therefore, it's leaving only 10 to 15% of the total loss, which is then dissipated into the switch room. Obviously, consideration has to be given to the outside air quality, but if it is suitable, using the heatsink cooling fans and appropriate mounting and ducting, the filtered external air at temperatures of up to 50 degrees centigrade, can be used to exhaust approximately 85 to 90% of the heat loss from these VSDs directly back outside the switch room. And this is done without affecting the switch room pressurization. And the switch room air conditioning system then only needs to be sized for the remaining 10 to 15% losses, which is actually going into the switch room. So utilizing this feature can dramatically reduce the air conditioning requirements of the switch rooms. And this then provides us a significant project cost saving, along with the operational ongoing cost savings compared to VSDs that don't have such a design feature. So if we take a look, what we do by means of back channel cooling, what we mean is we take the outside air either through into the back of the drive or through the bottom, whichever way we go in, we block off. So if we take the outside air in through the back inlet, we block off the bottom inlet. This air then goes through the back channel and we exhaust it back into the outside atmosphere by means of the back of the drive or through the top of the drive. And again, the same as what I said before, whichever means we use to extract, we block off. So if we go through the back inlet and out through and exhaust through the back exhaust, we would then block off the upper exhaust. This is where the IP54 seal I spoke about sits, and that prevents any pollutants from the outside atmosphere from going through into what you would call the operating parts of the drive, so the electronics. So no pollutants or any outside air is actually going into the drive itself. Now, when we showed this and use the back channel cooling as a value proposition, you can all of a sudden now see how the heat going into the switch room has reduced substantially. And when this was all put together, it was found that the total air conditioning savings, that was the air conditioners themselves, would give them a cost saving of between $140,000 to $165,000 for all the switch rooms. Now, the reason it's 140 to 165 because at the time we weren't sure which air conditioning units they were going to use because they didn't know themselves. And then, depending on which units they were going to use, that meant they had an operating cost saving of between $65,000 to $90,000 per annum. So quite a substantial saving, and this actually helped us to. We actually won this project by giving them this value proposition. Now, if we take a look at what we call the footprint, the size of the drive, electrical equipment on mines, it's usually installed in areas known as switch rooms, control rooms. Some call them substations, others call them e-houses. Now, these switch rooms quite often are built or constructed very often from normal shipping containers, 20-foot, 40-foot shipping containers. These are quite often used when mines are in hard to reach remote areas, because it's easy to load them onto the back of a truck, load them onto a ship if necessary, sail them up the coast, offload them, put them on the back of a truck, and then take them to site. Now, what is interesting to note, we have a manufacturer of what we call a modular type system that we've used in the past. And you can see from this e-house in the photograph, that it's actually built onto a skid. Now, what this company I'm talking about has done, they've actually built hydraulic legs onto the bottom of the modular system. So what happens is the installation is completed. And remember, with an installation such as this, everything can be tested before it actually leaves for site. So the factory acceptance testing can actually be done at the premises before it leaves. Now, what this company did with they've actually placed hydraulic legs on the bottom of their e-house. So what happens is when everything's finished, it's been tested, they raise the leg, the truck comes along, reverses underneath the building, they lower the legs so that the building is on the back of the truck. Obviously then it's secured. It drives to site, they lower the legs, the truck drives out. The truck drives out and the legs are then lowered to the required size, and everything is ready then for terminating, for landing, terminating the cables. And just as an example, to show how quick that everything can be completed, we did a few years ago, we did a installation for an iron ore mine down in the Northern Cape in South Africa. When the unit was put onto site it was four units. When they were put onto site, within 3 days, everything was connected up and running. So obviously that saved a lot of labor costs, and obviously with the site being up and running within three days, it meant they would go into production a lot quicker than what was expected. So again, we're looking at the same project, and this is again what we used as a value proposition. Was we looked at the size of all the manufacturers that were invited to tender, and you can see again that there's a distinct advantage with some manufacturers over others because the size of the drives are less. Right, Laura, I'd like to show a short video now. So I'm going to hand back to Laura because it will play better and you'll be able to hear the sound better, which basically is a short video that shows how this jigsaw all sort of fits together. Okay, so you can see from the video what I was talking about with the reduction in size. 73% reduction in the footprint, the size of the drive, and no reduction in the power output. And also the heat pipe technology that we utilize in the back channel. This is unique to Danfoss, and it enables us to reduce the heat going into the switch room. Now, also by reducing the size of the drive, you can see how we can reduce the size of the switch rooms. So this is quite a substantial saving on the capital costs, especially if you're looking at something like a brick building, which they sometimes used to use as switch rooms for the drives to be installed in. Now, Danfoss uses a system called automatic motor adaptation, and this is what we would call an auto tuning procedure, and it's recommended to be carried out during the commissioning phase. And what that does, it ensures that the VSD is matched to the motor and the installation. This then ensures we get optimum performance with improved overall system efficiency. It ensures that the motor runs quieter, you don't get that humming noise, and it is a quick and simple commissioning. And it also ensures that the cable between the variable speed drive and the motor is actually compensated for. Now, many VSDs offer a similar function today, but different to many competitors, the Danfoss drive performs this auto tuning without spinning the motor and without the need to decouple the motor from its load, be it a conveyor, it could be a pump, it could be a fan. And this saves time during the commissioning. But most importantly, it typically ensures that the procedure is done during commissioning. And if the motor has to be decoupled, quite often this tuning is overlooked during this commissioning phase, mainly due to time pressures. And then this will result in the plant operating at less than optimum performance for its lifetime. And why do I say that? Well, I worked in the electrical side of the mining industry, and no matter who delays a project, the poor electrical department is always the last ones being pushed to get everything done. So it doesn't matter whether it's the civils that ran late, whether it's the mechanical side that ran late, it's always the poor electrical department that is being pushed to finish. And it's always the electrical department that gets the blame because it's running late, even though it may not be their fault. So, assuming that this auto tuning improves the overall efficiency. So let's say the VSD and the motor combined, and if it's just, let's say conservatively by just 1%, based on the typical load profile, the reduction in the operating cost as a result of this improved efficiency equates to approximately 2 to 5% of the VSD, and remember that's year after year after year. Now, using a single drive for all equipment actually provides benefits during the both the commissioning and long-term operation in terms of operator familiarity, spares holding, and as a result of the common user interface, so the keypad, the display, the control, input, output parameters, and the programming. And the beauty of it is, if you have, for instance, 4 drives that will be programmed and the parameters set to do identical things, you only actually need to program one on the LCP, and then you just take that local control panel from the first one to the others with the same settings, because it's just like a personal computer. It's basically like a copy and paste, and it will fit those. It will set those drives to the same parameters as you'd set with the first one. Now, certain AC drives are designed for exactly the needs of mining and minerals processing plants. They have to cope with very extreme conditions, as we said earlier. Heavy loading, controlling equipment that's usually quite a long distance away. And it doesn't matter how well the plant has been designed, there's always a way to reduce these costs even further. And AC drives are very often used for just that purpose. And what does it do? Well, it extends the equipment lifetime, it optimizes the processes, it reduces maintenance, and it saves energy costs. Now, the mining and minerals industry presents some of the most challenging environments for production that I know, and the mine sites and mineral processing facilities and the associated stockyards, ports facilities, they're very often of a large scale and in remote locations. Now, in 2015, Danfoss acquired another drive manufacturer based in Finland called Valcon. And what that means is that when we combine the Danfoss product range and the Valcon product range, so in other words, we combine the product portfolio, it means we can address all low voltage variable speed drive application needs in the mining and minerals industry. So the key takeaways, well, capital expenditure savings. Yes, we can, because of the size of the drive, the footprint of the drive, we can reduce the size of the switch room. We can reduce the capital expenditure on the air conditioning units, so we can reduce those. And obviously on the drive itself, because obviously the smaller the drive, the lower the cost. Operating expenditure, well, with a drive, with a variable speed drive controlling a motor, it reduces the energy costs from the motor. We've already spoken about the air conditioning units. The smaller the air conditioning units, the lower the running costs. And also by using the automated the automatic motor adaptation, the AMA, the running costs is also a saving. And what does that leave us with? Well, it means the industry will be saving energy now and into the future. And remember, that is year after year after year. And just as a note, Danfoss, for anybody that's interested, Danfoss has a free learning site, e-learning program. So for anybody that's interested in learning more about variable speed drives, please feel free to go onto the site, have a look, and if you're interested, you can do those learning programs in your own time. If you're interested in attending another of the mining webinars that we're running at the moment, please contact me. My email address is on the slide, and I will get back to you and give you the details of when the other mining webinars are taking place. And the one thing about all of us within the Danfoss Drive division, we do have a passion for drives.
Stephen, thank you so much for such an insightful presentation. Some really interesting statistics that you've provided for our audience. I'm sure for those who weren't thinking about variable speed drives, they definitely are now. Definitely a really relevant topic for the mining industry at the moment. So I'm going to engage in a discussion with Stephen, have a chat with him around some of the pertinent topics that have come through his presentation. But I'd like to invite our audience to participate in a second poll that we are running. So our second poll is asking, has your institution invested or planned to invest in renewable energy or energy efficient alternatives? Either yes or no, or perhaps you're unsure. So again, please do participate in our second poll that we're running today. Has your institution invested or is planning to invest in renewable energy or energy efficient alternatives? If you can select one of the options, either yes, no, or unsure. So I'll give you again a few more seconds to think about the question and choose one of the options that we're providing. Great. Thanks everyone for participating in our second poll. Before I have a chat with Stephen, I'd like to invite Nicolette Pombo van Zyl to join us. She is the editor of ESI Africa and a really great energy expert in the field. So Nicolette, welcome.
Good morning, everyone, or good evening, depending on where you are in the world. And thank you so much to Steve and Laura for inviting me.
Brilliant, Nicolette. Thanks so much. Stephen, I've got some great questions based on your presentation. So if you will dive into some of those with me. First of all, Stephen, I'd really like your thoughts on the payback period on variable speed drives and how much cost savings does a variable speed drive actually offer compared to traditional motors?
Okay, the cost saving obviously would differ depending on whereabouts in the world you are, because obviously the cost of electricity is dependent on it's kilowatt hours, and depending where you are in the world, obviously these costs will vary. Now, as you could see from my, I presented the graph earlier with the fixed versus variable speed. Obviously, if you're not running a motor at full speed, then there is a cost saving. And if you remember, we showed that with a 20% reduction in the speed, it showed a 50% reduction in the energy usage. Now, we have an area where we conducted this. It's not actually on a mine, but what it was a water and wastewater plant in Europe. And again, based on obviously the payback period, obviously again depends on the size of the drive, the kilowatt ratings of the drive. And we looked at some 800 kilowatt drives, and on average, and what we found is that on average, the payback period on a drive, and especially around about the 800 kilowatt size, is around about an 18-month period.
Brilliant, Stephen. Thank you. Very, very valuable, if I do say so. So I also have a very interesting question coming through from our audience, Stephen, and they would like to know if there is a significant advantage in employing weatherproof variable speed drive controllers located in the field, in other words, local to the drive.
There are weatherproof drives available that can go into the field. The IP rating is IP66. There are limitations with regard to the Danfoss drives. but I think we go up to a range where we are quite competitive with our competitors. So we can go up to 90 kilowatts in a IP66, which basically IP66 means you can take a hose pipe and spray at the drive and it will have no effect. The one thing that where we've put these IP66 drives into situ, the only thing that I've sort of recommended is, because of mainly in South Africa or Africa, is that if they do put them into the field, is just to put a cover over the top to deflect the sunlight, because obviously it gets it can get very hot, and being in a metal enclosure, I mean, I think we all know, living in South Africa or Africa, what it's like if you go into a galvanized structure and stand in there in the heat of the day. I think you'll soon be running out. So it's just as a precaution, just to prevent it becoming overheated inside. But as far as the rain or anything, the weather, it would have no effect on it.
Okay, brilliant, Stephen. Thanks. I'm sure that's really helped our audience member. So I know Nicolette has one or two burning energy questions that she'd like to share with you, Stephen. So Nicolette, I'm just going to hand over to you.
All right. The first question that would come to mind, especially for the mining sector, is in relation to batteries and energy storage. And I see this is a marrying of two sectors here, because the mining sector absolutely needs battery storage when it comes to their off-grid energy applications, and they also then mining the minerals and ores that go into these battery technologies. So there's definitely a collaborating effect there. So Steve, in terms of that, do you see the use of these variable speed drives in assisting with operations in the mining sector?
Yeah, very good, Nicolette. Within Danfoss, we actually have a division that actually looks after the off-grid systems. And you're quite correct in what you were saying about the mining industry starting to look more towards that, and especially with battery storage systems, not so much for off-grid, but because the supply and the quality of supply is not that reliable, they actually looking to use it more for short-term grid stabilization, and it actually works out, or let's say it can work out more cost-effective than what they're using at the moment, which mainly seems to be diesel generators. So if you have a battery stack system, which obviously is a lot of batteries, usually built into a shipping containers, because shipping containers seems to be the favorite to be able to get these installations to site. And obviously it's quite a number of shipping containers, because it's virtually hundreds of batteries. But as I said, Danfoss has a division that looks after this side of things, and if anybody's interested, I mean, it's a subject matter on its own, and we have presentations on this subject matter. And if there is any interest out there, please contact me, and then I can arrange to put the whoever's interested in with the relevant personnel within Danfoss, and we can organize probably a virtual meeting, because this seems to be the way that everything's going at the moment. We can organize a virtual meeting and we can give you a lot more information on hybridization types.
And it's very interesting that you speak about hybridization now as well, because a lot of the mines are asking, what would the ideal hybrid energy solution look like for their mining sites? And I would say, and this is something that you have mentioned also in your presentation, that the ideal system is definitely something that is flexible, it's modular, and it includes the battery storage. And I think also that it is very important that the mining industry doesn't see themselves as energy producers, energy generators. So then looking at a relationship with an IPP that then owns that modular plant and then supplies the mining site with that energy. So, and I know that looking at that hybrid solution, the first thing that comes to mind is solar PV. And then combined with battery storage, that solar PV module can assist with making sure that the short drops in energy prevent the cycling of any diesel genset that is on site. So then in terms of the solution that Danfoss is offering, the variable speed drives, how does that then also assist with a hybrid system at a mining site?
Yeah, Nicolette. What Danfoss, obviously Danfoss doesn't put the whole package together itself. We have partners. So obviously we don't manufacture batteries. So we have parties that actually build these units. So correct what you're saying, inside the unit is the battery stacks. Obviously, you have to have transformers. Obviously, that has to be well ventilated, and the control philosophy also has to be correct, because obviously, if you're working grid and non-grid, you can't have the two connecting together onto the grid. Otherwise, there would be a big bang. So again, I reiterate what I said about the staff that we've got in Danfoss itself. They have some very, very good presentations that they can utilize with an end user if they're interested in this type of technology. Nicolette, I hope I've answered your question.
Yes, absolutely. And it's very interesting to know that Danfoss is really looking at the different factors within the mining and the energy sector. Thank you so much, Steve. Back over to you, Laura.
Nicolette, thanks. Some very, very engaging questions there with some really interesting outcomes, Stephen. Thank you. We do have time maybe just for one more question, Stephen. And what I'd really be interested to know, actually, based on everything you've said now for the last sort of almost 60 minutes, is how big has the uptake been from the mining sector in Africa for variable speed drives?
With new mining, there's starting to be a realization that it has benefits, so it's growing. With the older mines, maybe because they're coming to the end of their lifetime, there's maybe not as much interest, but if there's potential for the expansions and to still grow further on the older mines, we seem to find there's a little bit of a reluctance to spend money on variable speed drives. But you've seen from the presentation, obviously, that we can prove that there is cost savings to be had. And it could be that the mines are not wanting to invest too much at the moment with the situation, the scenario we're all living under at the moment. But from a long-term point of view, it would really pay the mining industry to consider a variable speed drive to control motors, because long-term, it will save them money.
Stephen, I couldn't agree with you more, and I really think from the message that you've given through today that our audience would definitely reconsider it if they haven't already. So thank you so much, Stephen, for your time today. And Nicolette, that's all we do have time for today. So on behalf of Danfoss and Mining Review Africa, I would like to thank Stephen for sharing his invaluable insights with us. I'd like to remind you that a recording of today's webinar will be available on demand on the Mining Review Africa website. So please stay safe and keep well, and thank you so much for joining us today. Goodbye.
Goodbye.